Hey guys, today we are going to start lesson 12.1 and to kick off unit 12, which is about statistics. And today we're just going to look at some different types of probability distributions. So what this is going to be is looking at some different ways to display data in order to find certain probabilities. So we're going to jump right in, and we're going to suppose that we did a survey asking how many siblings do you have? And these are all of our results. Some people said 3, someone said 2, someone said 3, someone said 0, etc. Each of these numbers represents the number of siblings that one person has. So what we're going to do is we are going to make a frequency table first. Frequency tables look a little something like this. We're going to draw it like this. And then what we're going to have is some rows for each one of these possible outcomes. So we're going to have 0, 1, 2, 3, 4. I'm going to make one more for 5 or more because there aren't very many there in that category. You could do a 5 and a 6, but if you do 5 or more, that would also be okay. So I'm going to draw a line, and then I'm going to leave some space and draw a total of 3 columns. So what this is the number of siblings, number of sibs. This is going to be our tally marks, and this is going to be our frequency, which is where we get the name frequency table from. And now I'm simply going to go through and count how many zeros are there, how many ones. And I'm going to do it like this. There are a couple different ways. I'm going to just go through and say, okay, I've got a 3, so I put a tally mark here. 2, cross that out, put a tally mark here, 3, and I'm going to go through this whole thing this way. Six is more than 5, so I'm putting that in the 5 or more column. So we've got 4, 0, 3, 1, 2, 1. If you can stay organized without crossing off each of these values, that's fine. But most people will find that they miss something if they don't do that. 2, 1. Oops, I just went the other way, but that's okay. 3, 4, and then 2 2s. 1 and 3. Okay. So one thing I could do to make sure that I've got them all is if I count them up, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28 total options. When I write down these frequencies, what frequency is saying is how many times did the answer of 0 siblings come up? Well, we tallied it up and it came up 3 times. How many times did the number of 1 siblings come up? It came up 6 times. 2 came up 8, 3 came up 5, 4 came up 3, and then 5 or more came up 3 times. And if I add up these numbers, this would give me 9 plus 8 is 17. 17 plus 5 is 22. 22 plus 3 is 25. Plus 3 is 28. So since I got a total of 28 and these match, that means that I did get all my values correctly. And this is the entire frequency table right here. Some of you are going to say, do I have to draw the tally part? Yes, you do. The tally is part of showing your work for the frequency table, so you do have to include this tally column if it says frequency tables. But this would be the entire problem. So let's try that again, but go ahead and make one for how many pets do you have? Pause the video, make your frequency table. If you want to do it on the board together as a group, you can. But make your frequency table, and then when you're done, come back and we'll check your work. Okay. So I'm going to make my frequency table. I'm going to say, I'm going to have 0, 1, 2, 3, and 4. All right. So I'm going to have the tally here in the middle. I'm going to have the frequency here. I'm just going to put that. All right. So how many times, or I'm going to go through and do my tallying now. So I've got 1, 3. I'm going to go through this real fast. I need a 5 column. I'm going to put 4 plus since it looks like there's only 2 5s. So I'll have 5. Stuff there. And 4. There we go. All right, so let's double count or double check to make sure we did this correct. Actually, let's find our frequencies first. So that would be 5, 6, 5, 6, 5. And then I'd have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27. Does that add up? So this would give us 10 and 15. 15 plus 12 is 27. So we did something correct. And again, this right here is our frequency table. So that is our final answer. All right. So cumulative probability takes multiple probabilities and says, answers a question like this. What is the probability that someone has more than 2 siblings? Now, this is going back to last semester, but this little p means probability of, and then whatever's inside. So this is saying probability of having more than 2 siblings. So if we go back to our siblings frequency distribution, we wanted, what was it, more than 2 siblings? So more than 2 siblings. To fit into that category, 2 is not more than 2. So really I'm just looking at 3, 4, and 5 plus. And what I'm going to do is I'm going to write each of these as fractions. And I have 28 total possibilities, but I'm taking 5 over 28. And then the other two are both 3. So plus 3 over 28 plus 3 over 28. So it could be that they have 3 siblings, they could have 4 siblings, or they could have 5 or more. So this would be all the possible results, and we would add all these up and get 5 plus 3 is 8, plus 3 is 11. So the probability that if we pick somebody else at random and ask them how many siblings do you have, the probability that they have more than 2 siblings is 11 out of 28. Now, you can leave that as a fraction if you want. I would recommend leaving it as a fraction because otherwise you're making extra work. But if you absolutely need to have it as a decimal, you can. You can put 0.39. We always write our probability as a number between 0 and 1, not as a percentage. So this would be our other option. But I would say leave it as a percent. Okay, what's the probability that they have at most 3 siblings? So let's look at which values make that statement be true. At most 3. So we could have 0, 1, 2, and in this case we could have 3 because it says at most 3. So in other words, it's like 3 or less. So the numbers that I'm looking at are 3, 6, 8, and 5. Now, here we wrote them all as fractions. The other thing we could do is write each of these numbers, 3, 6, 8, and 5. 3 plus 8 plus 6 plus 5. Did I write that correctly? Yeah. I wrote them in a different order, but I wrote the right numbers. And if I add these together, I'm going to get 3 plus 8 is 11. 6 plus 5 is also 11. So add those together and we get 22. And then write that over the 28 total. Either way it works. So if I simplify that, dividing by 2, I get 11 over 14, which would absolutely be a sufficient answer, but I could also do 11 divided by 14 and get 0.7, and that would round up to 79. I prefer 11 out of 14. If you insist on giving me a decimal, I'll allow it. So using our pet table, what's the probability that they have at least one pet? Well, looking back here, at least one means one or more. So that we could have this one, this one, this one, or this one. And if we add all of those together, we're going to get oh, and this time we had 27 possibilities. So we're going to have 6 out of 27 plus 5 out of 27 plus 6 out of 27 plus 5 out of 27. So that would give us 12 plus 10 is 22 out of 27. I can't simplify that. There's nothing that goes into both of those, so this would be a good final answer. For our decimal friends out there, if we do 22 divided by 27, we get 0.81. All right. Last one. Probability of someone having less than 3 pets. So not equal to 3, but less than 3. So this time, I am looking at 2, 1, and 0. So that's 5, 6, 5. So using our other method, we could go 5 plus 6 plus 5, which would give us 16 out of 27. And again, I can't simplify that, so that would be a good final answer. 16 divided by 27 gives us 0.59. So that's cumulative probability. The most important thing to do is to read these very carefully. So when it says something like more than 2 siblings, it's a matter of figuring out, does it mean greater than or greater than equal to? Does it mean less than or less than equal to? So ask yourself, if it says at most 3 siblings, do I include 3 or do I not include 3? That's the biggest challenge, I think, in doing these problems. Last type of problem we're looking at is probability distribution. So this says, suppose you flip 3 coins. Show the probability distribution for the number of heads flipped. So let's start drawing a little picture over here and think about, if I flip 3 coins, what are the possible outcomes of getting heads versus tails? So I could flip 3 coins the first time, and I could get all heads. The next time I could get 2 heads and then a tail on this one, but I could also get heads, tails, heads. I could get tails, heads, heads. So I could get 2 heads, but there's 3 different possible combinations of which coin it turns up tails. And kind of the same thing follows. If I then say, okay, what if only one of them comes up heads and the other 2 tails? Well, it could vary which order they go in. The order does matter of which coin is being flipped. So I could have something like this, tails, heads, tails, or I could have tails, tails, heads. And my last possible combination is that they could just come up all tails. So here I had 3 coins come up heads. There's no other way to rearrange those. They all came up heads. Here I had 2, and then I had 2 and 2. Here I had 1, 1, 1, and here I had 0. So what I'm going to do is I'm going to make a table like this. And this table is going to have 3 columns. Or sorry, 3 rows. First column, I'm going to write number of heads, or just number of each. And then I'm going to write frequency. How often does it happen, or is it possible to happen? And then what's the probability? So really, my only possible the number of heads that I could get are 0, 1, 2, or 3. It's not possible to get more than 3 because I'd have to have more than 3 coins. So how many times did 0 heads come up? It just came up the 1 time. So there's that. 3 came up once as well, so I'm going to go ahead and fill that one in. Both 2 and 1 came up a total of 3 times. So I'm going to put in 3, 3. And there were a total then of 8 possible outcomes. There are 8 possible outcomes for our coins. So our probability is going to be the frequency over the possibilities. So 1 over 8, 3 over 8, 3 over 8, and 1 over 8. These should all add up to equal 1 if we add up all those fractions. So that's just a brief introduction to statistics and probability. Here's your homework for tonight. Go ahead and get started on it. Help each other out, ask questions, and we can go over this when I get back.